Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, I'll be talking about one more example of partial pivoting, which is very important from the exam point of view. And we generally get such questions in the exam because they don't ask you to perform partial pivoting directly. So let us consider this question. If you have just logged into this particular video. So you can refer to the earlier videos to know what is the concept of partial pivoting. Partial pivoting is basically when we have drawback in the Gauss elimination method, we generally use pivoting. So in the pivoting, we have two types, partial and full. So I have already taken one example where I have performed partial pivoting. So this is another example. So Gauss elimination method generally has drawbacks where your pivot element becomes zero, then you perform partial pivoting, or when you have the round of errors, then also you perform partial pivoting. So let us consider this question. So let me just write the question. Okay. Solve the system of equations and the second one is x plus y is equal to 1 using a Gauss elimination method. With and without pivoting. So we'll be doing both in this particular question. We'll be assuming that the numbers are rounded off to 4 significant digits. So this is given to the in the question. So how to start? This is the system of equations that we have. Now, as we have given here with and without pivoting, you have to perform. So let me consider the first case when I'll be applying without pivoting. So applying the Gauss elimination. Without pivoting. So this is our first case. So in this, let me just so without pivoting, we'll be considering the first of all the augmented matrix. So here the augmented matrix is because we have two unknowns, two equations. This is what we have. Now, without pivoting, that means we'll be applying the normal Gauss elimination method. So our first pivot would be this. This is our pivot. So take A11 as the pivot and make A21 equal to 0 because you have to convert it into upper triangular matrix. So that's very simple. So I'll be taking the elementary row operation. R2 goes to R2 minus the A21 upon A11 R1. So this is nothing but A21 is 1 upon 0.0003 R1. So after the elementary row operations, I am getting the matrix as the first row remains as it is, no change. So the second row, this becomes 0. And this you can calculate. This would be 1 minus 3 times 3 upon 0.0003. So this becomes 1 minus 10,000. So that's nothing but minus 9999. Similarly, when you will calculate this, this is coming out to be minus 6666. So this is what we are getting as the answer in this. So now it has been converted into an upper triangular matrix because it's a 2 cross 2 matrix, right? So just apply the backward substitution. Now, when you apply the backward substitution, you can rewrite this equation. So, or I can write this as 0.0003 x, y. Now, using the backward substitution, what we are getting? Minus 9999y is equal to minus 6666. So this implies that y is equal to. So just keep in mind that you need to take 4 significant digits. So this is what we are getting as y. And from the another equation, I'll be getting my answer. So this will give me x as 0. Now, if I'm getting x as 0, is this a solution? So here I'm getting y. I'll write it because I need to highlight this. Why we are saying that we need to perform the partial pivoting. If you substitute here x is equal to 0 in the system of linear equations, okay, let us consider in this one, you will get the answer. But for this, when you put x is equal to 0, is y equal to 1? Is it? No, we are not getting y equal to 1. We are getting y as 0.6667. Don't round off. Just we are asking that is it a correct solution? No, we are not getting a correct solution here. So this solution is not true as it results in error. All right. So now we'll be moving ahead to the second case where I'll be applying the Gauss elimination method with pivoting. So let us consider now the case where I'll be finding out, I'll be applying Gauss elimination with pivoting. Now with pivoting, you just need to understand you have to choose the maximum magnitude element in the particular column. So consider your augmented matrix. That is 0.0003, 1, 3, 1. This is 1. So which element is of maximum magnitude out of these two? Because we are talking about the first column. So as A21 is of maximum magnitude, so interchange the rows. So we'll get 1, 1. Okay. Now we'll take A11, that is 1, as the pivot and make A21 equal to 0. For that, the elementary row operations that I'll be choosing would be the same. So here I am getting this as R2 goes to R2 minus so this is my elementary row operation. Now, when I'll apply this, what I'll get? So when we'll solve this, I'll be getting 3 minus 0.0003. That would be 2.9997. And this would be 1.9998. So using the back substitution as we have done here, I can rewrite this, or we can directly find the value as well. So using the backward substitution, okay, I'll write this, or I can write this as 1, 0, 1, 2.xy one 1.999. Now using the backward substitution, I'm getting 2 as this. So my y is coming out to be same. There is no change. Okay, so this is my value of y that I'm getting here. There is no change. But when I'm considering the another value, that is the value of x. So x plus y is equal to 1. Substituting this particular value in this, so I'll get 1 minus 0.6667. So I am getting here x as 0.3333. So this is my value of x. Now, when you'll substitute this particular value in the system of equations, you would notice that yes, you are getting the correct answer. Even the x plus y, when you will add these two values, you are getting the answer as 1. And also for the another equation, it is satisfying. That means x and y is the solution of both the equations. So now you can say that yes, we are getting the correct solution of the system of linear equations. So x is 0.3333 and y is 0.6667. So this is the system of linear equation, solution of the system of linear equations with and without pivoting. So this question is very, very important, and such questions you can expect in your exams. So in the next lecture, I'll be talking about the full pivoting, and please do stay tuned, and we'll have more to come in the upcoming videos. Thank you so much.